Hi, this is S. Lakshmanachari, working as Assistant Professor in Department of Cybersecurity, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to discuss the topic bus and memory transfers. So, in a digital system with many registers, it is impracticable to have data and control lines to directly allow each register to be loaded with the contents of every possible other register. So if you consider a digital system with a large number of registers, so it is very difficult to connect every register with the other register directly. So, uh, so if you connect directly one register with the another register, it requires more number of connecting wires. So that's why it is impracticable to connect one register with the other registers directly. So here, suppose if you have a n registers to connect directly with one with other registers, total we require n into n minus 1 registers. Suppose if you have a 10 registers, so you require 10 into 10 minus 1, so that is equal to 90. So 90 connecting wires are required. Suppose if the number is more than 10, it is very highly difficult to design to connect registers directly with each other. So that's why. So if the number of connecting wires also increases, then the cost also increases, because the cost is directly proportional to the number of connecting wires. As the number of connecting wires increases, the cost also increases. So that's why it is it is not a realistic approach. Okay, so it is not realistic approach when we are dealing with a larger digital system. So that's why we need to find another way or solution for this. So that is have a one centralized set of circuits for data transfer. That means here that is using bus. A bus is a group of wires that is called bus. That means a set of connecting wires are used to transfer the data from one register to the another register. So that is a bus. So using this bus with a less number of connecting wires, we can transfer information from one register to the another register without connecting directly with each other. So that is a use of the bus. So have control circuit to select which register is the source and which register is the destination. So we need the control circuits. We need the control circuit in order to select which register is the source and which register is the destination. Because in a digital system, we have large number of registers. So we need to specify from which register to which register we are transferring the data. So that's why by using these control circuits, we should specify which register is a source and which register is the destination. So this is a necessity of why we are using the bus system. Because if you use a conventional method, that means direct connections between the registers, it requires more cost. It is the complexity is also high. So that's why we need to take a different approach. So the different approach is the transfer of information using bus and memory transfer. So let's see how we can transfer the information using the bus. Okay, so a more efficient scheme for transferring information between registers in a multiple register configuration is the common bus system. Okay, so it is a efficient method. It is a transferring of information using common bus system. It is an efficient method than the conventional direct connections between the registers. So a common bus consists of a set of common lines, one for each bit of the register. So for we are using a common set of common lines for every bit of the register. Okay. And the control signals determines which register is selected by the bus during each particular register transfer. And here this common bus system we can implement in two ways, that are constructing the common bus system using multiplexer, and another way is the constructing the common bus system using tri-state buffers. So these are the two ways of constructing the common bus system. So let's start with the first way, that is using multiplexers. So multiplexer, it selects the source register whose binary information is then placed in bus. Okay. So multiplexer. So multiplexer is it is the combinational logic circuit that will select the register, that will select the source register from where the data transfer takes place. Then that information is given to the multiplexer. Then it will be passed on to the bus, common bus. Okay, so that is a process. So in order to understand this concept, let us consider a block diagram with a bus system for 4 registers. So it is constructed with the help of 4 4x1 multiplexers. So multiplexer means it is having n number of inputs and 1 output and 2 power n selection lines. Okay. So see here, multiplexer having 4 data inputs and 1 output and 2 selection inputs for the 4x1 multiplexer. So before going to the common bus system, we will have a look on 4x1 multiplexer. So this is a block diagram of the 4x1 multiplexer. So 4x1, so the 4 indicates the number of inputs and 1 indicate the output. So here we have 4 inputs, I0, I1, I2, I3. So these are the inputs and 1 output, that is Y. Okay. And here we require here 2 selection lines. One is S0 and another one is S1. So the number of inputs are 4. So we can write 2 power 2. So 2 power n. 2 power n. So where n is the number of selection lines. So here we require 2 selection lines. So S0, S1. So S1 and S0 are the selection lines. So based on that selection lines only, any one of the input will be connected to the output. So see here. So truth table. So this is a truth table. So input I0, I1, I2, I3. So based on the selection lines. So if the selection lines both are equal to the logic 0, 0 and 0, so the I0 input will be connected to the output. So at a time, only one of the input will be connected to the output. So during another time, if S1 is equal to 0, S0 is equal to 1, then I1 input will be connected to the output Y. Similarly, when S1 is equal to 1, S0 is equal to 0, so I2 will be connected to the output. Similarly, the last case is when both the selection lines are equal to logic 1, then the I3 input of the multiplexer will be connected to the output. So this is about the block diagram and the truth table of the 4 by 1 multiplexer. Okay, so now consider a common bus system using 4 registers. So here you can see we have a 4 registers: register A, register B, register C, and register D. So all these different registers, they are using a common bus system. That means a common set of wires are used to transfer the data from one register to the another register. So for this setup, it requires 4 by 1 multiplexers. So this is a mux 0, multiplexer 1, multiplexer 2, multiplexer 3. So total we require 4 multiplexers. The size of each multiplexer is 4 by 1. 4 by 1 means 4 inputs and 1 output and 2 selection inputs. Okay. So the inputs are 0, 1, 2, 3. So for the multiplexer 0, the inputs are A0, B0, C0, D0. Similarly, for multiplexer 1, the inputs are A1, B1, C1, D1. Similarly, for multiplexer 2, inputs are A2, B2, C2, D2. Similarly, multiplexer 3, it is having A3, A3, B3, C3, D3. Okay. So these are the inputs for every multiplexer and outputs. And the common selection lines. So selection lines are common for every multiplexer. So every multiplexer, it is having 2 selection lines that are S0 and S1. So these 2 are the selection lines. So based on these selection lines only, any one of the input will be connected to the output. Okay. So suppose if the if S1, S0 and S1 both are equal to 0. So the selection lines are S0, S1. Suppose if both are 0, 0. So if both are 0, 0, then I0 of the multiplexer will be connected to the output. So I0. So what is the I0 here? This one, 0. This one. So that means I0 of every multiplexer, it is connected A0, A1, A2, A3. So that means the register A is selected. The register A. Register A is selected. So that means here the 0 bit A0 is connected to I0 of multiplexer 0 and A1 is connected to I0 of multiplexer 1 and A2 connected to I0 of multiplexer 2, A3 connected to I0 of multiplexer 3. So that means when S0 and S1 both are equal to 0, the register A is selected to transfer the information through the common bus system. Okay. So suppose if the A0 is equal to 0, B0 is equal to 1, C0 is equal to 1 and D0 A3 is equal to 0. So then if the selection lines S0 and S1 are equal to 0, register A is selected and the data present in the register A is 0, 1, 1, 0. So this data or information is transferred to the common bus system through the multiplexers. So finally the output will be it will be 0, 1, 1, 0. So this is the output. So suppose if you want to transfer the data present in register D. So register D. So in order to select that register D, the selection lines both should be logic 1. So if both should be logic 1, so what will happen? So if the selection lines S1 is equal to 1, S0 is equal to S0 is equal to 1. If both the selection lines are equal to logic 1, then see that register D is selected. Register D. So because if selection lines are both are equal to 1, I3 of every multiplexer is selected. I3 of every multiplexer will be connected to the output. So for I3, the D register, D0 is connected to I3 of mux 0, D1 is connected to I3 of multiplexer 1, D2 is connected to the I3 of multiplexer 2, and D3 is connected to the I3 of multiplexer 3. So that means total all the bits of the register D is selected to transfer the data. So after choosing the selection lines both are ones, then whatever the data is present, that will be transferred to the common bus system. Okay. So when both selection lines are 1 1, then the register D will be selected. So in this way, based on the selection lines, that particular register will be selected. So this is a way of transferring the information from one register to the another register using common bus system. Okay, so see here. So this is the following functional table. So this is a functional table. It shows the registers that is selected by the bus for each of the 4 possible binary values of the selection lines. So already we know, based on the selection lines only, the particular register will be selected. Okay. So when both the selection lines 0 0, register A is selected. And when S1 is equal to 0, S0 is equal to 1, B register is selected. Similarly, when S1 is equal to 1, S0 is equal to 0, the register C is selected. Similarly, when all the selection lines are equal to logic 1, then the register D will be selected. So in this way, every register is selected to initiate the data transfer. And next one. So next one is a common bus system using tri-state buffer. So tri-state buffer. So the tri-state gates can be considered as a digital circuit. So tri-state gates are considered as a digital circuit with 3 gates. Okay. So 2 of which are signals equivalent to logic 1 and logic 0 in a conventional gate. So if you consider any conventional gate, basically 2 types of signals or levels are there, that are logic high and logic 0. Logic high or logic low. Logic high is represented with 1 and logic low is represented with 0. But here there is a third signal that is called high impedance state or high impedance signal. So that is a third state. Okay. So high impedance state is the state neither logic high nor logic low. So it is the most commonly used 3 state gates in case of bus system is buffer gate. Buffer gate. So the graphical symbol of the 3-state buffer you can see here. So this is a 3-state buffer. Okay. So it is having one input, another one output, and we have a control input. Okay, so your output will be depend upon this input C. If C is equal to 1, then only the input A will be connected to the output Y. Otherwise, the input A will not connected to the output Y. So this is a diagram. It demonstrates the construction of the common bus system with the 3-state buffers. So here we can see, so in order to construct a common bus system, here we are using 4 tri-state buffers. 4 tri-state buffer. So this is a tri-state buffer 1, 2, 3, 4. So total we are using 4. And these 4 tri-state buffers are controlled with the help of decoder, 2x4 decoder. Okay. So the decoder, 2x4 decoder. So it is having 2 inputs, A and B, and enable pin, enable, and 4 outputs. This is Y0, Y1, Y2, Y3, 4 outputs. So based on the input lines, the corresponding output will be activated. Okay. So here the register A, 4 registers are connected. Register A, register B, register C, register D. So based on the state of the tri-state buffer, any one of the input register will be selected to transfer the data. Okay. So here you can see the truth table. So inputs. What are the inputs? So inputs are enable, and inputs A, inputs B, and outputs, 4 outputs, Y0, Y1, Y2, Y3. So if the enable pin is disabled, if enable is equal to 0, logic 0, then you will not get any output. So even the if enable pin is equal to 0, even if we apply input, we will not get any output. So we will get the output only if the enable input is equal to logic high. So see, when enable is equal to logic high, and if inputs A and B are 0, 0. So if the inputs A and B are is equal to logic 0, then Y0 output is equal to logic high. So Y0 will be logic high. During that time, the remaining all Y1, Y2, Y3 are logic zeros. So the control input to the first tri-state buffer is logic 1, and for remaining tri-state buffers logic 0. So that means the second tri-state buffer, third, fourth tri-state buffers will be disabled. Only the first tri-state buffer will be activated. Only the first tri-state buffer will be enabled. So because of this high impedance input is equal to 1, that register A will be connected to the output. Okay. So that is in this way, only one register will be selected to transfer the data. Okay. Similarly, the second case. So in order to get the output at the output of the decoder, so enable pin should be logic high. And when A is equal to 0, B equal to 1, then Y1 is equal to 1, and the remaining all will be 0. Remaining all outputs are 0. Similarly, when A is equal to 1, B is equal to 0, then Y2 output will be 1, and the remaining Y0, Y1, Y3 are equal to 0. And the last case is when A and B are both are equal to 1 1. So when both A and B both are A and B inputs of the decoder are is equal to logic 1, then y3 will become 1 and the remaining all are zeros. So that means here 1 and the remaining first, second and the third tri-state buffers will be disabled and only the fourth tri-state buffer will be activated. So that means register D is selected to transfer the data to the output. So in this way, only one register can be selected using the decoder. Okay. So the outputs generated by the four buffers are connected to form a single bus line. And only one buffer can be active state at any given point of time. So only one buffer will be activated at a time, at any point of time. And the control inputs to the buffers determine which of the four normal inputs will communicate with the bus line. And a 2x4 decoder ensures that no more than one control input is active at any given point of time. So this is how we are constructing a common bus system using tri-state buffers. And coming to the memory transfer. So already we know memory is used to store some information or data. So using that memory, we can perform two types of operations, that are memory read or memory write. So both operations we can perform with the memory. So the most of the standard notations used for specifying operations on memory transfer as stated below. So the transfer of information from a memory unit to the end user, from the memory unit to the end user. So for we have a memory like this. So this is a memory. So memory contains multiple memory locations, and every memory location is identified with a memory address. Suppose if it is having some 4000, 4001, 4002, 4003. So every memory location it is having some unique address. So using that unique address, we will identify the memory location, and we can perform memory read or memory write operation. So the transfer of information from one memory unit to the end user. So this is a memory. So from the memory unit to the end user. So that is called memory read operation. Memory read. Similarly, the transfer of new information into the new information to be stored in memory, that is called write operation. So that means we have a new data. So that data we are going to store inside the memory. So that is this one. So that is called memory write operation. And a memory word is designed by the letter M. So in every memory location we can store some data like 10110 like that. So this is called a memory word. So that is represented with a capital M, memory word. So memory word is nothing but it is a group of 16 bits, that is called memory word. And we must specify the address of the memory word while writing the memory transfer operations. And here already we have seen two types of operations with the memory, that are memory read and memory write. In order to perform these two operations, we have registers, that are address register, that is represented with AR, and a data register that is represented with DR. So using these two registers, we can perform either memory read operation or memory write operation. So let's see how we can perform the memory read operation. So memory read operation we are performing with this one, M of AR to the DR. So consider a memory. So the address of every memory location. Okay, so this is a memory. So now consider a read operation. Read operation is nothing but reading the data from the memory to the end user. So to the end user. Okay, so M of AR. So if you want to perform the read operation, we are reading the memory. So that means if you want to read a memory location, we require the memory address. So that memory address will be stored in the address register. So suppose we are reading this memory location. If we are reading this memory location, then what is the address of that location? 44000. So that will be stored in the address register. So in that address, we have some data. So that data will be copied to the DR register, data register. So DR, data register. So this is a read operation. So read statement, it causes transfer of information into the data register from memory word selected by the address register AR. Okay, I hope it is clear. And coming to the another operation, that is a write operation. Write operation is nothing but storing a new information into the memory. So here you can see R1 arrow M of AR. That means in a R1 register we have some information. That information we are going to store in the memory location whose address is specified by the address register. So let us assume the address register AR is equal to 4003. So we have a R1 register. In R1 register we have some data. Like that, some data is there. So this data we are storing inside the memory, and the address of the memory location is specified by the address register. So what is the address register? What is the address stored in the address register? 4003. So this data, the R1 register data, will be copied to the 4003 location. So this is called memory write operation. So the write statement causes transfer of information from register R1 into the memory word selected by the AR register. Okay, so in this video we have seen how to transfer the data from one register to the another register using common bus system. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.